All right, hello and happy Wednesday. Today is December 16th. We are taking today to finish up our final product, which is the Save the Egg TCT for Forces in Motion. Tomorrow and Friday will be makeup and recovery days, SDL days for students who are behind. For those of you who are on track or ahead, you can work on additional focus areas or power focus areas for the coming units. But we are going to jump into our Forces in Motion project. We're scrolling down to the Save the Egg TCT. We're going to open this up. You will be getting scored on modeling and constructing an evidence-based explanation. So that is what your COG skills are going to be focused on. We did A and B Monday. There's a video linked on the 6th grade checkpoint document, which is right here. It's in Google Classroom under classwork. And this was going over A and B. Today, we're going to talk a little bit more about C and D. Yesterday, we also talked about C, but we are going to go more in depth today. I'm going to zoom this in. All right. Okay, so just to kind of remind you what was happening with this Save the Egg TCT, there were a group of students who decided to drop an egg using a parachute, and they had 3 different size parachutes, a 5-inch parachute, a 10-inch parachute, and a 15-inch parachute. And as they dropped the parachute in the egg, they did a time trial 5 times. They dropped it 5 times, and they timed it each time. For the 5-inch parachute, the average drop time was 5 seconds. For the 10-inch parachute, the average drop time was 10.2 seconds. And for the 15-inch parachute, the average drop time was 17.6 seconds. I hope I'm saying seconds and not inches. It's seconds if I said inches ever. So we discussed that basically as the parachute gets larger, the drop time increases. And we talked about there were 2 different forces that were at work here: gravity, where the egg's falling to the ground, and the air resistance that's kind of stopping the egg from falling as quickly. Eventually, as the parachute's getting larger, causing the egg to land with less force and making it land softer. So, excited by what they observed in the data, the students wanted to better understand what actually caused the change in drop time. They realized that a longer drop time resulted in the egg hitting the ground with less force. So they thought it might be useful to create models to help understand the forces acting on the egg for different parachute sizes. So in C, you're going to use the diagrams below to model the forces acting on a falling egg for each parachute size. Use arrows to model the force due to gravity and the force of air resistance. So we're going to have 2 different arrows for each parachute. Make sure that the length of the arrows represents the relative size of each force acting on the egg for that parachute configuration. So instead of having a number that represents the newtons or the force acting upon the egg and the parachute, we're just going to use arrows. So I'm going to do the first one for you. I'm going to tell you what the arrow should look like for the first one. So I'm going to click Insert, Shape, Arrows, and I'm going to do a down arrow for gravity. So in the 5-inch parachute time drop, the average drop took about 5 seconds. That's pretty quick. Gravity is working much harder than air resistance. So my gravity arrow is going to be larger for the parachute that is 5 inches. So I'm going to make my gravity arrow blue. Air resistance is not working very hard because it's not slowing down the drop time. So I'm going to insert, shape, arrow, draw an arrow. I'm not going to make it as big because air resistance is not as strong here. And the egg, if it's dropping at 5 seconds, it's probably going to fall and it's probably going to crack because it's dropping so quickly. Okay, so gravity is stronger than air resistance in the first parachute. Okay, so what I want you to think about as you continue to draw your arrows is at 10 inches, is gravity stronger or is air resistance stronger? Or are they close to the same? One is stronger than the other. It falls in about 10.2 seconds. It's still falling with quite a bit of force. And then for the 15-inch parachute, which one is stronger? It took 17.6 seconds for the 15-inch parachute average to fall to the ground. So air resistance is working pretty hard there. So which arrow should be larger? Think about that. I'm not going to give you all the answers because you're getting a score for modeling, and I want you to try to model this. You got your 5-inch parachute, so everyone should get that right. I want you to try the others on your own. Okay, for part D, I'm going to zoom in. It says you're going to use the force diagram models from part C to estimate the relative net force on the falling egg for each configuration. You're going to construct an explanation for why increasing parachute size results in the egg hitting the ground with a smaller force, thus saving the egg. Support your explanation using the force models and analysis of net force for each configuration. So basically what you're doing is you are going to tell me how these diagrams with the arrows show you which force is stronger or which force is weaker, and what that is doing to the egg. As the parachute gets larger, is that causing the egg to fall slower? Yes, we've talked about that. So what's that doing to the force as the egg is hitting the ground? At 5 inches, at a 5-inch parachute, the egg's falling quickly. That force is hitting the ground, or that egg is hitting the ground with quite a bit of force. So what's happening as the parachute gets larger? You will need to use capital letters at the beginning of your sentence and periods at the end to answer this question. If you need extra help, let us know. Other than that, have a wonderful day, and we will see you later.